Okay, so in the last video I went through some basic examples of how to write a list, where we basically just define a list, just like I've done up here. And in today's video I'm basically going to go through some more ways to both generate lists, but also how to take a list and filter out certain things of it and basically generate a new list. The first thing that we're going to go through is generating a list with intervals. So let's say that we start with a list of ints, and instead of doing the normal way where we type that list is equal to and then typing all of the numbers, we can do, let's say that we start at 1 and then we type ... and then where we want to end. So let's say 10. If I were to generate this code, see that I get a list going from 1 to 10. Let's say I only want the odd numbers between 1 and 20. Then I can add a step here. I just type 1 and 3, and Haskell is actually smart enough. So this is basically gonna be our step every time. So this step is by 2. So every other step is also gonna be by 2. So if I type list, you see that we get every odd number. And we could also do this for even by just changing it to 2 and 4. Where to reload list, you see I can get that. And we can also work backwards, but the default step is basically 1 upwards, meaning that if I were to type 10.1, this would actually generate an infinite list, or would probably return an error because it can never reach 1. So I actually have to add a 9 here. We work backwards in our steps. So in this case, our step is 1. If I were to do that, you can see that it goes down to 1. We can, of course, do this for lists of characters or strings instead. Let's remove that. I just type with characters instead. And characters have an index in Haskell, and that is why we can do this. So let's say that I did this, and I reload my code. I would actually get the lower capital alphabet. I can also add a step in between here. Let's say that I want to move by 2 each time. So I just type in a C, which is the third letter. And if I were to type this list, I would basically shrink the alphabet in half. You can go from large letters to small letters. Let's say that I wanted to move from the large A to the small c. This, on the other hand, will generate some maybe unwanted stuff. You will get a few weird signs here in the middle, and that is basically because the indexing in Haskell works that the large letter alphabets are smaller than these signs, and then the lower capital letters are larger than that. So this is basically the size order, basically. But enough with generating lists. Let's say that I wanted to take a list. Let's say this random list here. Let's say that I was given this by someone as an input, and I wanted to filter out all of the odd numbers of this list. Well, let's first create a helping function. Okay, let's say that I have a function isEven, which takes in a list of integers. So it's gonna take in this random list. Or no, let's actually say that it's let's say that it just takes an int here, and it returns a bool. So it returns basically true or false. And let's just call the input x. And let's say that if x mod by 2 is equal to 0, so if it's even, this is basically mod by 2, because let's say I had a 2 or a 4 here, that would be a 0. Then let's return true, else let's return false. Okay, so here we move on to list comprehension. Let me just clear this. So in list comprehension, we will basically have, let's say that we named this even checker. So we have a function here, even checker, which is gonna take in a list of integers. So in this case, it would take in this list, and it would also return a list of integers. Okay. So let's say that even checker takes in a list, and checker takes in a list. Let's call this list that it takes in. We can name this anything. Let's just name it. Let's just name it X. Make it simple, okay? Or maybe not. Let's name it XS, just because we don't want to have this here. Maybe that's confusing for new people. So the way that list comprehension works is basically you will make these list signs, and we will basically have an output followed by one of these large eyes. I don't know what they are called, and we will have the range. Okay, we will have the range of the function, and we will have a filter here. Okay, so this is basically the setup for the list comprehension function, or whatever you want to call it. It's list comprehension. Let's start with this range. The range is maybe a bit confusing if you haven't read like math. We're basically gonna use this little letter here. So let's actually say that we create a list here. Okay, let's just name this checklist. We type this sign, but we type it in this way. This is actually gonna mimic this, this is basically gonna say that checklist checklist is basically this sign basically means that elements of checklists belongs to XS in this case. So if I were to type XS here, that basically means that our checklist is basically gonna take upon itself every value of our input. So let's say that the input is random list, then our checklist is gonna take on every value of this list, but one after another. Okay, so it's basically gonna start on the first, it's gonna start on the one, and then it's gonna try our filter. If it's good, then it's gonna become the output. So our output would be checklist in this case. Okay, so now the filter here. So let's say that we wanted to just keep the even numbers. We could actually use our help function here. So we have is even x here, right? We can actually type is even, and we send in our checklist in this case, right? We don't want to send in the entire list, because our helper function here, it just takes an int and it returns a bool. And also this checklist is basically gonna take upon itself every value here, right? It's gonna go one after another. It's gonna check this is even checklist, and then if it's true, then it's gonna say nice, we keep this in the list. And if it's false, let's say for 9, it's gonna check and it's false, then it's gonna say okay, we don't keep this, and then it just moves on to the next. Okay, so let's say that I were to type even checker with our random list here. You see, it would return 32, which is our first even, then 2, 6, and then it would move on to 72. So we just had 4 even numbers. We could, of course, turn this. Let's say that we wanted to keep all the odd numbers. Let's call this even odd instead. And let's do this, and let's flip this. So it returns false if it is even, and true if it's not even, right? So now, let's say that we sent in 9. It's gonna take the 9, check here, and the 9 modded by 2 is not 0, right? So wait, yeah, exactly. So then it's true, right? Because we wanna keep the odd numbers. So let's say that we did even checker. Oh, this is maybe an unfitting name now, because now we're checking for odd numbers, but oh well. Let's say even checker with our random list. This would return all of the odd numbers in our list. Yeah, so this is basically how to filter out stuff. You can have very complex helper functions here. and I think I'm gonna elaborate further in the next video, just to make this even clearer, because this is very useful in Haskell. Not quite as useful as maybe recursion, but it's very, very useful. But yeah, that's it for today.